Right. Okay. So yesterday, right. So everybody should have one worksheet with you, okay, on bonding. So those of you who have attended yesterday's makeup class, you will know like the what domain means, okay. And for those of you who haven't attended, I've prepared for you a worksheet, okay, so we can go through this together, okay. So we are all on the same page. So yesterday we said domains are groups of electrons. So these domains can be either bonding domain, you see, okay, or lone pair domain, not bonding domain. So I have written it down for you already in here under electron domains. So you see under electron domains, you have bonding domain and non-bonding domain. Yeah, to help you understand what this means, I have 3 examples here: NH3, CO2, and CH4, which I want you all to draw on the page. So we have NH3, CO2, and CH4. Can you use the method I taught you not long ago, like this method, to figure out the structural formula, okay, of CO2, NH3, and CH4. Okay, I'll give you all like 1 minute. Okay, if you don't remember what steps we can use, you can refer to this page. First, you have to sum up the total number of outermost shell electrons. Then you need to assume that all the atoms are stable. And then you subtract the answer you get in step 1 and 2, okay, from one another. And finally, you can find the number of non-bonding electrons by subtracting the answer from step 1 and step 3. Okay, so let's do this together. So you have 1 minute. Okay, let me copy this first. And I'll paste this over maybe here. Okay, so what will you get for NH3, CO2, and CH4? I'll give you the group number. Nitrogen is from group 5. Hydrogen it belongs to no group. Carbon belongs to group 4. Okay, and oxygen belongs to group 6. And finally here you have anionic carbon, which is also from group 4, and hydrogen, it doesn't belong to any group. So what do we do in step 1? We sum up the valence electron, or the outermost shell electron. So how many outermost shell electrons are there in total for NH3? 8, yes, correct. Because we have 5 plus 1 times 3, okay? Yeah, you can take out the calculator if you are not too confident, okay, with mathematics. So you have 5 plus 1 times 3, because nitrogen has 5 outermost shell electrons, hydrogen has 1, and then we have 3 of them, so 8. What about the second step here? What does hydrogen and other atoms want? Hydrogen wants only 2, and nitrogen wants 8. So what would the calculation become? 8 plus 2 times 3. Why is it 8 plus 2 times 3? Because nitrogen wants 8, right? Hydrogen wants 2. So what would the sum be? What would the sum be? 14, yes, okay. So step 3. Step 3 is where you subtract the answers you just got, okay, from step 1 and 2. What do you get when you subtract them? 6, yes, okay. Can you do 14 minus 8 equals 6? How many bonds does 6 electrons translate to? 3 bonds, because each bond contains 2 electrons. Finally, when you subtract the answer from step 1 and 3, what do you get? Be careful, like I mentioned, you don't subtract things of incompatible units together. You are subtracting 6 electrons from 8 electrons. You are not subtracting 3 bonds from 8 electrons because they don't have compatible unit electron at all. So you subtract these two things go with the unit electron together. So what is the answer? 2, yes. So 8 minus 6 gives 2. How many lone pair does 2 electron translate to? 1. So 1 lone pair. So now, can you draw NH3? Can you draw NH3 in the blank space provided on your worksheet? So what do you rely on to draw the structure? You know there are 3 bonds, and that there is 1 lone pair, and that these are the atoms. How are you going to put 3 bonds and 1 lone pairs around these atoms to make sure that everybody is stable? Where must the 3 bonds go? You mean pointing from drawn between nitrogen and hydrogen, right? Yeah. So I mean these are the only 3 places you can put the bonds. There's not a 4th place where you can put a bond. As a bond has to exist between atoms. What about the only lone pair? On nitrogen. Yes. So you can draw it here. Okay, like this. So this is what you need to draw on the worksheet. Okay, under NH3. This is what you need to draw. And in the exam, you will just be given the periodic table with the group number, and you have to figure it all out from step 1 to step 4. Okay, yeah, I know that's a lot to ask for, but it's just the same step, okay, for all these examples. So now, I'll give you all 1 minute, really. Yeah, the second example, you're on your own, because I'm not there in the exam. Okay, so CO2 and CH4, you need to work this out yourself now, okay, using the same method. Work on this together. Okay, 1 minute. And students at the back, you're part of the class. You need to work on the worksheet together. Okay? And can you put away your phone? Can you put away your phone? We are working on the worksheet together. So we'll be checking the answer for CO2 and CH4 in 1 minute. Okay? Refer back to those steps. We just use the same steps, okay, to get to this structure. So you're going to use it on CO2 and CH4 as well. Carbon is from group 4, oxygen is from group 6. So for CO2, you need to sum up the number of outer molecular electrons, which is 4 plus 6 times 2. Because there are 2 O and only 1 C. So this is why we need to do 4 plus 6 times 2. The 2 comes from the formula CO2. Okay, CO2. Okay, this is 4 plus 6 times 2 equals 6, yes. Okay, so 8 electrons in 4. So 4 bonds must exist between atoms. So this is actually a double and this is one. 2 plus 2 gives 4. Yes, okay, you might want to change the lone pair as well. Yes, but then you want to draw these 2 lines separately. Instead of yeah, but this structure is correct. Just don't draw the 2 lines all at 3 p.m. or yes. Just get to this answer. You need to do some calculation. Or if you maybe already know, yeah, it maybe just look at it. Yeah, but I think the safest approach is to follow the test. But if you already know the number, then you can just follow Yes, and then the second step is where you put down the numbers that each atom prefer. Any atom other carbon and hydrogen, they will prefer 8 electrons. So therefore, 8 plus 8 times 2. Okay, let me write this out. So you have 4 plus 6 times 2, because this is a carbon, this is a oxygen, and this is where the 2 comes in. 16 electrons, that is. And the second step is where you put down the number of electrons the atoms are after, which is 8 plus 8 times 2. So this is what they want. Carbon wants to have 8, oxygen wants to have 8. So this is why I put 8 for both. Times 2 because they have 2 oxygen. So that gives 24. When you subtract the answer from step 1 and 2, you get, what do you get? You get 8. What does 8 electron translate to? How many bonds? 4. So you have 4 bonds. Right? You need to practice more, which is why I have loads of examples on the back. Okay, if you are quick, you can work on those first. Okay, while I continue the session with the other students. So you have 4 bonds here, and then for the last step, what is the answer to the last step? 16 minus 8 is 8. Yes, so 16 minus 8 is 8. That means you have how many lone pairs? 4 lone pairs. So put these together. So when you put 4 bonds and 4 lone pairs together, what is the structure like? So yeah, just now when I walk around, I noticed some students, okay, not just one, okay, drew just a single bond in here. That cannot be true because you have 4 bonds. You need to have 4 bonds put between atoms, and this is one way to put it. Yeah, so you can't just put 1 bond here and 1 bond there because you will underutilize the bond if you just put a single bond here and there. So make sure you have 2 double bonds at these locations. Where else do you put the lone pairs? Where should you put the lone pairs? Should we put any on C? No, C is happy, it's satisfied. Okay, it has already 8. So we put 2 on each oxygen. So like this. So this is CO2. And finally, for CH4, I'll just draw you the answer. Okay, because it is really just the same step. Okay, so you have this. And my question is, how many domains are there around the central atom? So can you use a different highlighter to indicate where the central atom is at? Well, of course you know what central atom means. It's the one at the center. You have to now count how many bonding domains and non-bonding domains are there around the central atom. So around N, how many domains are there around N? There are 4, okay? So there is 1 non-bonding domain up top, and there are 3 bonding domains at the bottom, right? You see? So can you put down bonding domain times 3? So there are 3 bonding domains, and there's 1 non-bonding domain, the one in yellow. We only look at the things around the central atom. So can you fill this out for me now, next, okay, for CO2 and CH4. How many bonding domains and non-bonding domains are there around the central atom C? How many? How many groups of electrons are there around C? Just 2, okay? Remember a single bond, this is what I wrote in here. A single bond and a double bond and a triple bond, they are all considered as one domain, okay? So therefore, you see only 2 domains in here. The first domain, the second domain. I know this is a double bond. If you think this is double bond, yes, you're right. But a double bond and a single bond, they are both considered as a bonding domain. So how many bonding domains are there? 2. How many non-bonding domains are there? None. Do you see any yellow stuff on top or around the green carbon? No, there are no non-bonding electrons. These are non-bonding electrons, but they are not around carbon. They are around oxygen. We only focus on those around the central atom. So finally, how many domains are there around the C and CH4? 4, right? So you have 1, 2, 3, 4. So the answer is 4 and 0. Is that clear? Okay? So once you figure out the total number of domains, so what is the total number of domains? For NH3, how many domains are there in total? What is 3 plus 1? 4. What about CO2? 2. And finally, 4. Yes, so 4, 2, and 4. And this is where we should fill out the bottom half of the page. You see, I drew, I included 5 blanks here for you to draw what the domain shape is like when you have different numbers. Okay, and for those of you who have attended yesterday's makeup class, you already know this. And for those of you who missed the class, make sure you watch that YouTube video I posted. And can you copy this? Copy this down on your table. Okay, so you have 2 domains, 3 domains, 4 domains, 5 domains, and 6 domains. Because domains, they are a group of negatively charged electrons. They will want to repel one another. Okay, think of them as like 2 guys who hate one another. They want to be as far away as possible. So this is why they form an angle of 180 between them. And because this is the furthest they can get. Yes? Sorry? How do you draw it? You just draw 2 lobes. Yeah, to leave like structure. Okay? For 3 domains, the furthest they can get is 120 degrees apart, right? Yeah, you cannot think of a structure that will have these domains further apart than 120. So this is why, for 3 domains, they have the shape, trigonal planar. 2 domains, we say the shape is linear. 4 domains is where this angle here is actually not 90, can you correct that? Yeah, it's actually 109.5, I forgot to fix it. But don't worry, you don't have to remember the angle. It's just for your information only, okay? So you can choose not to include the angle. But the shape is important. These words in yellow and the shape in purple, you need to know. So draw out the shapes in purple in the table and write down the name of the shapes under each. I need you to remember. 2 domain is linear. 3 domain is trigonal planar. 4 domain is tetrahedral. 5 domain is trigonal bipyramidal. And 6 domain is octahedral. Good morning. You're not here to sleep. Right. So now, anytime you see 4 domains, the domains have to be put like these. Okay? And so on the next page, actually on the next page you see some blank space in here. Yeah, blank space. There should be one blank side on the other side of the page. Yeah, so can you put down for NH3 as there are 4 domains. So CO2 has 2 domains. CH4 has 4 domains. Okay, so CO2 has 2 domains, CH4 has 4 domains. So how are you going to draw the 4 domains in here? Let's find out. So 2 domains will always look like this. 4 domains will always look like this. Okay, so we will convert these structures we just drew, NH3, CO2, and CH4, into the bottom drawing. Yes?
How do you count the domain?
Oh, you calculate the number of domains first by drawing it. Like, let me get this number. You need to first do these calculations on top. Then you can find the number of bonds and no pairs. And what you need to do is to draw the structures out and then count how many domains there are, like we just did. So what is a domain? A single bond is considered as a domain. A double bond is also considered as a domain. Basically, anytime you see a group of electrons, that's a domain. So you have 1 group, 2 group, 3 group, 4 group. So 4 domains. Why are there just 2 domains here? Because you have 1 group of electrons, 2 groups of electrons. So 2 domains. And here, 1 group, 2 group, 3 group, 4 group. 4 domains. Just counting. Okay. Of course, you need to do those calculations on top first before you can get to this stage, right? Yeah. So when you go back here, we have the 4 domains, 2 domains, and 4 domains. This this is how you know you must draw something that looks like this. So you have 4 domains, 2 domains, and 4 domains. But these domains, some are bonding, some are non-bonding. Okay, so you need to reflect that now. Okay, so you have a non-bonding domain here, and then you have 3 bonding domains. So we draw it like this. So we have NH3. And then these are the bonding domains, right, you see. So do you remember the shape of this molecule? Yeah, let me pull out that, the simulation is still here, okay. So let's go back to what happens when we have 3 bonding domains and 1 non-bonding domain. So take a look at the simulation, please. So you have 3 bonding domains. So these are bonding domains. This thing that looks like a ghost, okay, it is a lone pair. It is a non-bonding domain. When we consider the shape of molecule, we will ignore the non-bonding domain because it is invisible. We can only see all the atoms that are bonded together by a bond. So can you see that the name of the shape is trigonal pyramidal? That's because when we connect these atoms together, we'll get something looking like a pyramid, right? Looking like a pyramid. So this molecule of NH3 therefore has this shape trigonal pyramidal. So can you write down the name of the shape? So trigonal pyramidal. As it looks like a pyramid that you will find in Egypt. Okay, so this is trigonal pyramidal. Trigonal means it has a triangular base. Yeah. What about CO2? When you put CO2 back into this structure here, and you put back the bonds, can you tell me what is the name of this shape? Linear, yeah. So this is linear because you basically see just a rod. Okay, this is a rod, and we don't call it a rod in chemistry. We say it has linear shape, a straight line. Finally, for CH4, what happens when you fit this bond back into this structure here? You have C, and then you have H's off at the side. Yeah, remember we said what this wedge line and the dashed line represent. Wedge line means it's sticking out. It's pointing towards you, okay, the audience. The dashed line means it's pointing away from you. It's pointing into the bond, So this is what we call perspective drawing. And can you identify the shape of this molecule? When you look at all the atoms now, and you connect them, what is the name of this shape? This is pyramidal. A pyramid is shorter than it is wide. A tetrahedral shape, however, is as tall as it is wide. Okay, or I should say all 6 sides are equal. So this is what a tetrahedral means. Okay, so you have to draw this in here. Okay, these 3 molecules, they correspond to NH3, CO2, and CH4. Write down the name of the shape there. Okay, and then now on the right you have a very scary looking page. Okay, on the opposite side here, see some very big numbers. Okay, that's for you to draw. Okay, some examples of molecules. Okay, so can you all very quickly copy this down first onto this line, copy it in this line, and then we will turn to this table next. We'll turn to this table next. Yes? Yes, yeah, you need to copy this onto the cipher, yes. Okay? And then we'll look at the opposite side of the page. 2, 3, 4, 5, 6. What do they mean? They are the total number of domains. So note that domains, they can either be bonding or non-bonding. Okay, so well, this is actually where you can put them. Okay, so can you help me copy this onto this worksheet now? So especially for those who have missed yesterday's class. 2 domains. What do you have to fill in? 2 domains can only be 2 bonding domain plus 0 non-bonding domain. So can you fill this in? And there are actually 2 blanks for bonding and non-bonding. So put down 2 bonding domain and 0 non-bonding domain. 2 bonding domain, and you see I wrote nothing about non-bonding domain because they are not. This is 0, and this is 2. So 2 and 0. So 3, yes. Yeah. For 3 domains, it can only all be bonding domains. So we put 3 bonding domains and 0 non-bonding domain here. But starting with 4, we have some variations, okay? 4 domains are interesting because they have 3 possibilities, okay? The 3 possibilities are, they can all be bonding domains. So of the 4 domains, they can all be bonding domains. Or it can be a combination of 3 plus 1. You know 3 plus 1 is 4, right? 2 plus 2 is also 4. So you can have different combination of bonding and non-bonding domains. That could add up to a total of 4 domains. Okay, so this is why I have 3 boxes here. Into the first box, write down 4 bonding and 0 non-bonding. In the second box, you write 3 bonding and 1 non-bonding. Finally, we have 2 bonding and 2 non-bonding. Okay? And the other 2 is also pretty simple, yes. 5 and 6. Write down 5 and 6 first. Oh, this one is actually an extra additional. Okay, so you can get all this. Okay, but you can add this back, okay? That will not appear in the exam. So you have, these are what will appear in the exam. You have a total of 1, 2, 3, 4, 5, 6, 7. 7 possible shapes. Okay, why are there 7 possible shapes? You see there are different description here. Each is different, okay? And you need to draw it in the box below. I mean inside each box now. So draw it. So for 2 domains, draw out one of these 2 examples. In here, you can draw CO2. I like to draw CO2 here. More so than BeCO2 because BeCO2 breaks the octet rule. And then in this box, you can put down BF3. Just pick either because you don't have space to draw both. And for 4, you draw either, and then for this one you can draw NH3 and then you draw H2O in it. Okay, so can you do that now? Yeah, and then use a different highlighter to highlight the different domains. Use maybe blue for bonding domain and yellow for non-bonding domain. Okay, so you just have to copy one of each into the box. Right? Because now we are going to use this to solve the problems on the back that I see some students have already started working on. Yeah, so if you're done with this already, you can move on to the next page where we draw the shape of these normal molecules. Yeah. Look that in exam, they will ask you to draw molecules that you haven't seen before. How do we predict the shape of the molecule? It's the same rules as before. We find out how many bonds and how many lone pairs there are, and then we fit it, okay, into this table to see, to see which one describes the molecule we have in hand. So very quickly copy this first. Yeah, so copy this first. Okay, this will be on the test. Okay, and we have the test on organic chem next week. Next week organic chemist. Right? Now that the whole class is here, I need to make this clear. Okay. So, right. And then we will look at the molecules on the back once you are done copying. Right. So they are, make sure you don't miss also the name of the shape. I'll ask you about the shape later. So 2 domains, when they are both bonding, is linear. 3 domains, when they are all bonding domains, trigonal planar. 4 domains, when they are all bonding, is tetrahedral. When 3 are bonding, 1 is non-bonding, trigonal pyramidal. Yeah, I know this is a nightmare to memorize, but you have to, okay, remember it, okay, the whole thing, okay. I won't give it to you in the exam or in test, okay. So you have 3 domains that are bonding, 1 bond, non-bonding domain will be trigonal pyramidal. When you have 2 plus 2 is V-shape or bend. And 5 and 6 domains, they are rather simple because they can only all be bonding domains. So, yes. So to test whether you can apply, can you turn over to the other page, okay, where there are many molecules here, okay? So you need to, I will select a few and you can work on this now, okay? We can work on this now. So let's try NCl3 and maybe let's try like maybe CS2, okay? O3. Maybe not O3. Okay, let's just try CH2O. So, can you work on this now? Okay, we have the same step as before. So, right. I'll give you the group number. Yeah, just work on B. So this is B, question B. This is question J. And this is question S. Yeah, and if you're quick, you can also work on, for question F, can you help me change CHN back into HCN? So I know I wrote CHN. Can you change this to HCN? Yeah, I'll give you the group number. Okay, so I'll give you the group number. So this is group 5, chlorine is group 7, C is group 4, sulfur is group 6. Right. You need to really be familiar with these steps. Okay, again, like the table, these steps will not be provided to you. Okay, so we'll just work on one of these together, and then I'll need you to finish the other 3 as homework. Okay, you don't have to finish all, there's too many. Okay, just finish these 4. B, S, F, and J. Yeah, B, S, F, and J. Okay, so try these 4. We will work on the first one together. Yeah, everyone should be working on this now. Okay, question B. Okay, so nitrogen is from group 5, chlorine is from group 7. Just remember what to do. You should use a calculator, okay? To make sure you don't make mistakes. We'll check the answer in 1 minute. After step 4, you need to figure out how many domains there are. Okay, so how many domains? And then draw, you fit the bonds and the lone pairs into those domains and then match it against the table. And then you will be able to find the answer. Okay, yeah, this is the step that you should always follow. Yeah, you can write down this shape. You can look at the domains around the center and only around the center. And you don't have to count how many there are on the scan. You can work on J, S, and F if you're done with B. So you have less to work on as homework. Okay, so J, S, and F, they are homework questions. Okay, you need to hand this in. So write your name, okay, on the side of the page. So let's check the answer. Anyone can tell me what step 1 would give you? 26, yes, okay. 5 plus 7 times 3, good. Don't forget to do that, electrons, 26 electrons. What about step 2? What does nitrogen and chlorine desire? They want how many electrons in the outermost shell, both of them? 8. So what is the answer? 32. 8 plus 8 times 3. Or of course you can do 8 times 4, doesn't matter. What about step 3? 6. 32 minus 26 is 6. Okay, so 32 minus 26, which means there are how many bonds? 3 bonds, yes. Okay, so you divide the number of bonding electrons by 2 to get to the number of bonds. Last but certainly not least, what is the number of non-bonding electrons? 20 electrons, because 26 minus 6 is 20. And how many lone pairs does 20 electrons translate to? 10, yes. And you will need to use just these 2 pieces of information to construct the structure. So can you tell me, if N is at the center, chlorines are on the side, how are you going to fit the 3 bonds and 10 lone pairs around the atoms to satisfy everyone? Yeah, so where do you put the bonds? Between the N and the Cl, right? No other places, right? Yeah, so we put this in here. What about the 10 lone pairs? Well, there seems to be a lot, but how many should I put on each Cl? 3. Does everyone get why we need 3 lone pairs on each Cl? Because if you don't put 3 lone pairs in here, chlorine will not be stable. So we need a total of 9 lone pairs of the 10 just to satisfy Cl. Where must the remaining one go? On N. Can everyone follow? Okay? Right. Focus on the central atom. Now that everything is worked out, you need to just look at the central atom. Tell me how many domains there are around the central atom. How many? 4, yes. 3 are bonding. 1 is non-bonding. Can you check this against the table? Tell me what is the name of this shape? When you have, yeah, I hear the answer already. Trigonal pyramidal. Can you find this here? So trigonal pyramidal is, I think this one. Yeah, the middle one. Okay, so you can check this against the page on the page before. When you have 3 bonding domain and 1 non-bonding domain, the name of this shape is trigonal pyramidal. So this is how you get to the shape. So can you draw this? So we can convert this into a structure that looks like this. Whenever you have 4 domains, the 4 domains must arrange themselves like this. And when you fit this molecule, NCl3, back into here, you will have something that looks like this, NCl3. So the name of this shape is trigonal pyramidal. Okay, so you only have to work on 2 more, actually 3 more questions as homework later. Okay, so finish these 3 because I need to move on to the next part. Okay, is everyone clear? You see, it's a long journey from the formula to the shape, and there's no shortcut. Okay, unfortunately, you have to go through step 1, 2, 3, 4, and then do some counting before you can finally. You even have to check it against the table. But this table, you need to memorize. Okay, so don't lose this page. Okay, can you make sure you circle J, S, and F, and hand it as homework? Okay, if you're done now, okay, yeah, you can hand it in. Okay, if you think you have already got the structure. Okay, but for those of you who still haven't figured it out, finish it as homework. Yeah, but copy this first. Have you all copied this onto your page? And write down the name of the shape. Trigonal pyramidal. And then we move on to the next page. So on the next page, we look at polarity, which is an even stranger concept to you, polarity. So you know the Earth has 2 poles, North Pole and South Pole. Okay, molecule can also have poles. Okay, positive poles and negative poles. So this is what we will turn to next, the concept of polarity. Okay, yeah, now I'll move on. Okay, to the next thing. So here on your notebook, now you have to write this on your notebook. I didn't make any notes for this part for today, so you have to take out your notebook now and write down the new title for today. Polarity of bonds. Okay, so you know a bond is like some kind of like a connection or marriage between 2 atoms. When 2 atoms form a bond, sometimes it's not a very like a harmonious relationship. You see, okay. Sometimes the bond may have some distortion of electrons. Okay, so let me explain what that means. First, can you put that? This is what a bond is. So a bond holds 2 atoms together. So holds 2 atoms together. So you can compare a bond to like what happens in a tug of war game. So this is one person. So they are holding out a rope. and then here's another person, okay, he or she is also holding at the other end of the rope. And the bond, okay, is kind of like, so this is the bond, okay, the rope that they are holding in between them. And you know there will be a towel hanging out, okay, from the middle of this rope in a tug of war game. So the position of this towel represents, okay, whether the electrons in the bond are shared evenly between the two atoms. So this is another look at the same bond. We have A, the atom, and then we have B. You should remember learning this in Form 4, where we put a pair of electrons in between, right? Does it ring a bell? Yeah, so this is, what kind of bond is this? Is it covalent or is it ionic? Covalent. Yeah, ionic bond don't have overlapping region. Covalent bond has overlapping region. So can you put that? This is one look of a bond. This is the other look of the same bond, okay? And what I want to show you here is that a bond, okay, a single bond contains two electrons. Yeah, so two bonding electrons, which is why you see one dot and one cross there. So two bonding electrons. But then, like I said, sometimes the bond is not like an equal sharing of electrons, okay? Sometimes the bond may look like this, okay? So you will have, at the beginning, when the two atoms attract the bonding electrons evenly, you have a covalent bond. So this is a covalent bond. Because the electrons is shared right in between them, it's a very even type of sharing. Sometimes, especially when one of the contestants here, you see, is like more muscular, okay, like that, okay, like yeah, you get what I mean. Okay. So you see, he's more muscular, and he will be able to pull the bonding electron closer to himself than to the other contestant. You see, and this type of bond is what we call an ionic bond. So this is an ionic bond. So you see, it is pulling on the rope more strongly than the other contestant. Yeah, and on top, and in the top example, the two contestants, they are pulling on the rope equally, so that the towel rests in between them. Covalent bond, if you remember, we describe it as, is it a sharing or transfer of electron? Covalent bond is sharing. Remember, this is why we drew overlapping areas. When you share things with another person, let's say you are sharing book with another person, you put the book in between the two of you, right? And this is exactly what happened. When a towel is resting right between the two contestants, this is a form of sharing. So write this word, a very, very important word on your notebook. Sharing of electrons. Sometimes, however, these bonding relationships is not all that, harmonious, okay? You see, one contestant may actually be very, very strong, okay? Much stronger than the other one. In this case, he pulled the towel towards himself, so that from the point of view of this contestant, he has lost some electrons. As these electrons, it is not shared anymore. It's not shared between them anymore. Instead, it gets pulled all the way to the stronger contestant. So we call ionic bond a transfer of electron. In that, this contestant, take a look at him. He has lost some electron. He lost some grams here. And this other strong contestant, he gained some electron. So transfer of electron means one atom lost electron and the other atom gained electron. While sharing means nobody gains. Everybody is just sharing. When you're sharing a book with your partner, none of you gain the book. Because the book is still between the two of you. Just sharing. That's what sharing means. Sharing means nobody is gaining, nobody is losing. But transfer is different. Transfer means somebody has lost electron and somebody has gained electron. Do you get me so far first? Now, of course, in an exam, we can't use the tug of war analogy, okay? Which is why we need to turn it into a chemistry, a proper term in chemistry. You see these strengths, different strengths, okay, of attraction. We call this electronegativity. So, but first of all, you can put down the tug of war analogy here first. So this is what I mean by the tug of war analogy. And what does this force of attraction mean? So these are forces of attraction known as electronegativity. So this is a very, very long word. So write this down for me, please. A keyword. Electronegativity. Okay? En. So from now on, I'll write this as En. In exam, you must at least write this word in full at least once. And then you can bracket En and then just keep on referring to this as En. Okay? So, different atoms, how do we know which atom is like this muscular contestant? Which atom is a weaker, okay, contestant? Well, we look at the periodic table. So this is the periodic table, the outline of it at least. We know that the electronegativity, when you go across the period, it will increase. Okay, so can you put down this trend for me? The electronegativity will increase across a period, meaning when you go from left to right on the periodic table. For example, from Na, Mg, Al, so Al is here, sorry, and then Si, S, Cl, Al. As you go from Na to Al, Al is a stronger contestant than Na because it is found further to the right. This is what electronegativity increases across the period mean. However, when you go from like the top to bottom here, Li, Na, K, and Rb, when you compare Li and Rb, which of these is a stronger contestant? Well, we say it is Li because electronegativity it decreases down the group. Okay, you need to remember these two trends. As you go down a group, which of these atoms is the stronger contestant, has a stronger electronegativity? Li. Okay, the one near the top is stronger. And what about when you compare left and right? Is it the left contestant or the right contestant that is more electronegative?
Right.
The right. Okay, so now let me ask you a question. Which corner? You know there are only 4 corners on the periodic table. Which corner on the periodic table has the atom with the highest electronegativity?
Top right.
Top right. Very good. Okay, put down this question. So, which corner of the periodic table has the most electronegative atoms? And the answer is top right, correct. So top right. However, the noble gases, they are exempted from this discussion. Why?
They're
What do you know about noble gases? Do they form bonds?
offset.
They don't form bonds. So this is why noble gas, they will never take part in this type of war game. They don't form bonds. So they don't need to hold ropes with, hold on to ropes with other contestants. They don't take part in the game. They are just spectators, you can say. They just watch. So the noble gases, can you put down another very commonly asked question? Okay, it is, why do we not include noble gases in here? That's because noble gases do not form bonds. So noble gases, first of all, write down, do not have En values. Okay, well, some do, but those are exceptions. And that's because they don't form bonds. So because they don't form bonds, due to their stability, so because they are stable, so they don't form bonds. Right, so therefore they do not have electronegativity. And now we need to look at something called the Pauling scale. Okay, so the Pauling scale will be provided to you in the exam. So here, I have this found already. So this is, the Pauling's electronegativity scale. Right, so we have, this is the Pauling's electronegativity scale. Can you see that? What do you see when you look at the right whole plot? Not applicable. They do not have electronegativity like we saw, okay? So don't be too surprised when you see that, oh, they have no value. Why is that? Now you know, they don't form bonds. But then, you should see something that is kind of obvious, okay, on the periodic table. What do you see happens to the value as you go from left to right? It increases. It becomes larger. This is what I said earlier. Electronegativity increases. And as you go down, you can see that the value, they are indeed growing smaller. Okay, generally, I know it doesn't go down anymore. this point, okay? But yeah, generally. So this is the trend you need to know. But then you may be asking, so what exactly is electronegativity, right? We now need to know the formal definition. Okay, so the formal definition. Electronegativity is the ability, okay? So it's the ability of an atom to attract electron in a bond. In other words, the higher the electronegativity, the stronger, okay, the attraction for electron. So to attract electron in a bond, and write down this relationship. The higher the En of an atom, so the higher the En of an atom, the more strongly it attracts electron. So the more strongly it attracts electron. Which brings us to the difference between ionic and covalent bond. Do you remember how we define ionic and covalent bond in S4 in Form 4? How do you know if two atoms form covalent bond or two atoms will form ionic bond? Yes, and let me tell you that this definition has some flaws, okay, in itself. So write down the proper definition of an ionic bond. Back then in Form 4, we can only put it that way because you only know very little about chemistry, like metal, non-metal, when you find it. Now that you know more in chemistry, we can, let's not say it is a wrong definition, let's just say it has some, imperfection, that definition. Now we refine this definition a little bit more. Can you put this down? In Form 4, we learned that ionic bond is formed between metal and non-metal. But I wanted to put a tick and a cross here. As you will see, actually, as you saw, I should say. Do you remember AlCl3? Okay, I think last lesson, Alex asked me about AlCl3. And you asked, why is this a covalent molecule, right? When we have a metal and non-metal. This is what I said. Like the definition we use in Form 4 is flawed, okay? It's not really just a bond formed between metal and non-metal. So now we're here to refine it. Put down the not so good definition first. So ionic bond is formed between metal and non-metal. This is a not so good definition. And covalent bond is formed between non-metals only. So what is a better definition then? So it's defined based on electronegativity. So electronegativity. When you have large difference in electronegativity, so this means difference in electronegativity. So I'll write one here. So difference in electronegativity. Delta means difference. Okay, you know this in math. Delta Y over delta X. So the bond is ionic. When you have small electronegativity difference, the bond is covalent. So this is a much better definition. A much better definition now. Okay? So when you look at Al and Cl, let's prove why AlCl3 is actually covalent. Can you find the difference between 1.5 and 3?
1.5.
It's still 1.5. Okay, and 1.5 is a kind of small value. In fact, the cutoff value is 1.8. If the difference in electronegativity exceeds or match 1.8, we say the bond is an ionic bond. If the difference in electronegativity is lower than 1.8, we say it is a covalent bond. So this is better. Okay, this is much better. So this is why, look at AlCl and NaCl. So I can tell you that the bond between NaCl is actually ionic, because when you find the difference between Na and Cl and between Al and Cl, you will find that where's Na here? Na is 0.9, the electronegativity. You don't have to memorize these values. So this is the one thing you don't have to memorize in this chapter. Okay, so you have 3.0, and aluminum is 1.5, and this is 3.0. What is the bonding nature of NaCl? Is it ionic or is it covalent?
Ionic.
It's ionic. Why is that? Because when you find the delta En It is 3 minus 0.9, which is 2.1. 2.1 exceeds 1.8. So this is ionic. What about AlCl3?
1.5.
Covalent, yeah. So the bonding nature of AlCl3, when we compute the delta EN, it's 3.0 minus 1.5, which is 1.5. 1.5 sits here. So AlCl3 is covalent. Is that clear? Okay, this is a much better definition if you ask me. So write down ionic, covalent. Okay? Don't just say, oh yeah, they both have metal and non-metal, so ionic. No. I wish things were that simple. Okay, but in reality things aren't that simple. Okay? So this is a very important concept. We say this is how we determine the nature of a bond. By nature, I mean whether it is ionic or covalent. So the nature of a bond. So nature can mean one of two things here. Ionic, which is it transfer or sharing? Ionic? Transfer. Or covalent, which means sharing. Okay? Now, we need to look at the concept of polar and non-polar bonds. Okay? So we have, can you put down polar bonds versus non-polar bonds? Okay? You can only use the term polar and non-polar to describe covalent bond. Okay? So the term polar and non-polar can only be used to describe covalent bond. You cannot use this word to describe ionic bond. Okay? So can only be used to describe covalent bonds. This is why I lay out my discussion like this. Okay, I have to let you know what a covalent bond first. And then you will know that in covalent bond we have two subtypes. Polar covalent bonds, non-polar covalent bonds. Okay? Let me use two very, very simple examples here. Cl-Cl bond. This is a covalent bond because when you find the difference in electronegativity, you don't even have to calculate. The difference is zero. Okay? When the difference is zero, it means it must be a covalent bond, and zero is less than 1.8. But when you have HCl, it is still a covalent bond. What is the difference in electronegativity? It's 0.9. Okay, so 2.1 and 3.0. The difference is 0, which is smaller than 1.8, so covalent. And in here, the difference is 0.9, which is still less than 1.8. It is still covalent. However, can you tell me which of these atoms is a stronger contestant in the tug of war game? Cl. Cl attracts the electron more strongly. So if I were to exaggerate this like a bond, in ClCl, the bonding electron will be right in between them. This is a very even form of sharing. But in HCl, okay, I said I'm going to exaggerate this a little bit, so let me elongate this line first. The bonding electron will actually not be found at the middle. It will actually be found closer to Cl than it is to H, right? Because this is similar to which analogy we used earlier. It's similar to this one. So let me just copy this from before. So we have this here. So in our first example, a Cl-Cl bond is analogous to this. And an HCl bond is analogous to this. Okay, so this is why the bonding electron is at the center and the bonding electron is closer to this guy. So when this happens, we say the molecule does not have an even distribution of electrons. So this yellow, like a shaded region here, shows you how the electrons are distributed in the molecule. You see this is kind of even, right? It's kind of even on the left. Okay, electrons are distributed equally. Okay, among these two atoms. Maybe let me not draw a narrowing in the middle. Let me draw it like this. It's even. But for HCl, because Cl draws on the electron more like strongly, you will see something that looks like this. It's like a pear shape, right? As Cl attracts the electron more strongly than H. So the electron gets pulled to one side. Okay? So which end has more? Which end has has more electrons now, H or Cl? Cl, right? Yeah, so this represents chemical dynamics. This shows the electron distribution. Okay, the yellow region describes how the electrons are distributed. As a result of this, we say the Cl(n) will be delta negative, okay, and the hydrogen N will be delta positive. What does delta positive and delta negative mean? Delta positive means electron poor. I like to think of this as like a bankrupt person. He's bankrupt. This guy is bankrupt because his money got wrong by somebody else, by Cl. And Cl is a rich guy because he is made rich by stealing electron from H. So we have delta negative meaning electron rich, and delta positive meaning electron poor. Do you get why we have a positive and a negative charge region on this bond first? Okay, or no? Do you get what is happening first? Yes. Delta positive means it has electron pulled away from it, which is why it becomes positive. Okay? Becoming positive means you have lost electron. And becoming negative means you have gained electron. Okay? So you have this N in here. And in chemistry, we need to draw another thing known as a dipole. Take a look at the word dipole for a moment first. Di means two. Pole, you know pole means, there's a positive pole and negative pole. So dipole, therefore, is an arrow that points from the delta positive end to the negative end of the molecule. Yeah, do you all know what vector is? Vector, V-E-C-T-O-R, in math or in physics?
Direction.
Direction, yeah, they have direction. Okay, so dipole is a vector, it's a direction. It's kind of like a way to tell which atom is attracting electron more strongly. So it always points towards the stronger atom. So it's kind of like a judge. Think of the dipole as like a judge. You say who is winning, who is getting an upper hand in a tug of war game. It's always pointing at a strong guy. This is what a dipole. A dipole is just a direction, pointing at the stronger guy. Okay? We will need to draw a dipole, right? Write this down. A dipole always points, so it is an arrow that points from the less electronegative to the, okay, yeah, we'll pick up next time, but put this down first. From the less electronegative to the more electronegative atom. Okay? Less electronegative to the more electronegative atom. So you have a lot to review today. And you have homework. Don't tell me you didn't get this page, okay? So we need to work on one of the 4 questions. B, J, S, F. Circle this. Send it in. Okay? And please pause the videos on the makeup class. We only have a few students in the makeup class. That's not ideal. Yes, I upload it after every day. You find it in the channel.